Okay, so you learned yesterday how to take two functions, f of x and g of x, and multiply them, add them, subtract them, even divide them, and then you learned how to do the domains. I'm going to review that with you first, but then the new thing for today, for those that are like seeing if this is the right video to watch, the new thing we're actually doing is compositions of functions like f of g of x. That'll be the new thing for today and how to do their domains. All right. So let's do a couple functions that you'd be able to find these for fairly easily. Let's say this is x plus 5. You'd be able to find the domain for that. Right away, that's what I do. The problem gives you this. It does not give you the domain. You have to make the domain. So I'd call that df. That means domain of f. d sub f. Okay, everybody do the domain for that one while I'm writing out this other one. X over x minus 2. Make the domain for g, otherwise known as dg. Okay, I'm going to pause for a second while you figure out those two domains. Because that's how you should start every problem. Start writing out what their domains are. Okay, so I'm back from the little break there. Hopefully you knew that this part right here had to be set greater than or equal to 0. So I go off to the side and say x plus 5 greater than or equal to 0. X greater than or equal to negative 5. So here's negative 5. Here's an empty spot. And it has to be greater than that. Oh, you're right. You're right. I was going to check it at the end. And then it's greater than or equal to, so I fill in the dot. Good. Okay. And now I'm going to go over to the other one. And the other one has x over x minus 2. It's just the bottom we got to worry about there, and we should set it not equal to 0. X minus 2 is not equal to 0. X is not equal to 2. Otherwise, it'll crash. So here's 2, and here's not equaling 2, and everything else should work. Okay, there's my two domains. Now, what you're going to be tasked with is, in a typical problem, find f plus g of x. Okay, go ahead and do that one. F plus g of x. Noticing a few cell phones out on desks, and they're not breaking rules quite this yet, but they should not be out on the desks. So that's the easy part. Just add them. Square root of x plus 5 plus x over x minus 2. Now, if we got really picky with you and asked you to add them with make a common denominator and actually add them together, this one's a fraction and this one's not, I'm going to find out for you how picky we're going to be on the test. But normally I wouldn't have expected you to add those together. If you had to get a common denominator, though, do you get this guy's denominator is a 1? Did you know that? Okay, and then the next step would be, if you wanted a common denominator, you multiply this one by x minus 2 here. And if you do it there, you got to do it on top also. And actually, that would be it. That's all you could do, because you can't multiply a square root with a parenthesis. You can't do that. That doesn't work. You can leave it like that. So your answer would be square root of x plus 5 times x minus 2. Can't even multiply it out. And then plus x all over the common denominator of x minus 2. Looks really impressive. That's something we could ask you to do if we're going to go hardcore with this, and I don't know, to be honest, if we're going to. But assume for a moment that you don't have to do all of that. Then this part's really easy. You just say plus. All right, now, how do I do the domain? I overlap them. I look at the domain of G, or sorry, domain of F first usually, and then the domain of G, and I just see where they overlap. And what I mean by overlap is where this one is actually above this one. And here's 2 is more like here. And I hope you could tell me then, where do they overlap? From here to here? And from there to infinity. Can you write that out? Go ahead, give it a shot. Write that answer out with a brackets and a parentheses and stuff. So then that's negative 5 to 2, union with 2 to infinity. Raise your hand if you had that one right. Okay, good. That's the simplest kind. The next step up kind is this. You learned this yesterday. What if you divide f divided by g? I'm going to go back to my original functions here and do it on this page, just so that I don't have to rewrite those functions out again. So I'm going to leave my domains up there too, because then I don't have to rewrite all of them. And let's just do f over g. See if you can figure out what the answer to f over g is, and then do its domain. You're figuring out f over g right now. Okay, so here we go. F over g. Well, the f's this, square root of x plus 5. The g is that, x over x minus 2. And if you left it that way, you'll get it marked wrong, because that's not simplified. That is a fraction over a fraction, and you need to know how to do that. I have been pounding this on my top 20 sheet, 2/3 over 5/7 for a reason, because you got to know how to take the fraction over the fraction and flip the one over. This one gets flipped, and you multiply. Get what I did there? Remember that? Now you multiply across the top, so it'll be like 14 over 15. That's how you do that kind of thing. Well, then how do I do this one? One of them isn't a fraction. My advice on that is fractions play nice with other fractions. So make this into a fraction on top. Put it over 1. Now it's a fraction over a fraction. And I can change it into a multiply. So I'm going to go square root of x plus 5 over 1. It's the same thing as square root of x plus 5. And instead of divide by, I'm going to say times. And then flip it. X minus 2 over x. When you actually multiply that out, remember, square roots can't get multiplied out with other stuff. So you just leave it. X plus 5. And the other one, I guess I'd put it in parentheses, x minus 2. Otherwise, you're going to think that just the x is getting multiplied by the square root all over x. That would be the final answer. And that one I know we would expect you to simplify the fraction. That's why I keep pounding on that fraction over fraction thing. It's going to happen a ton in pre-calc. It's also going to happen when you have like sine over cosine over sine. In about a month, you'll know how to answer that question. And it's not that hard. You just flip and multiply, and everything cancels, and the answer is 1. But there'll be more complicated ones when you get into, well, see, if I flip like this and multiply, flip it over. Oh, I actually was wrong. It's not. The way I set it up, this one, when I flip it and multiply, I would actually get sine squared over cosine squared. And that equal to tangent squared. But you will learn that later. Okay. Anyway, the point is you got to know this fraction over fraction stuff. Get used to it. Okay, so if I were to do f over g's domain now, that's got 3 parts to it. It's got 3 number lines you have to overlap. Do you remember this? You got the 2 parent ones, df and dg. df and dg. But with divide, you have a 3rd number line to watch out for. It's whatever would make the bottom one, in this case g, whatever would make g of x equal to 0. So we got to say g of x cannot equal 0 is our 3rd number line. All right, so this one I already knew. That's part of the beauty of doing it up ahead of time is you already have d of f right there. And so I'm going to say from -5 to infinity. And then g of g, that's that one with the 2, empty spot at the 2. It goes like this. But I have to throw in a 3rd number line now, where g of x cannot be 0. I go back to g of x. That's this. And a lot of people don't know how to make that 0. They know how to crash it. See, people will say, oh, x can't be 2. That makes it crash. That doesn't make it 0. What makes g of x equal to 0? If I put in 0. Because the 0 on the top makes anything equal to 0. The only exception is 0 over 0, which is technically undefined. But if there's a 0 on the top and anything else on the bottom, it's going to equal 0. So yeah, if I put in x equals 0. So 0 would be right about here on the number line. So it can't be 0. But when it comes to making g of x equal to 0, that's the only thing that does make it 0. We're not talking about crashing. We're talking about making it 0. So this one's really complicated. Where does it overlap? In this little zone. Again in this little zone. And again in that zone. All right. That's add, subtract, multiply, and divide. All go like that. And the divide one is the complicated one, has an extra restriction. Okay. Now I want to make sure you really got that. I'm going to give you two new functions. I want you to divide them and tell me their domain. Okay. Square root of x minus 1 is f of x. And g of x is x over x plus 7. Okay, tell me what's f over g, and then what's its domain of f over g. You'll need 3 number lines to make this work. Here we go. Here's what you should have said. F over g is simple. Square root of x minus 1 over x plus 7. That has to flip and multiply. I would recommend that you put this over 1, and then you go times, and then you put x plus 7 on top over x. Final answer. Square root of x minus 1 times x plus 7 over x. Raise your hand if you had that one right. Awesome. Now the hard part. 3 number lines. df, dg, and g cannot be 0. G of x, technically. Anyway. All right, d of f is, this has to be x minus 1 greater than or equal to 0, x greater than or equal to 1. So here's a 1, greater than or equal to 1. Or equal to, yes. Okay, the next one. That would be if x is 0. Oh, wait, no. First I'm doing domain of g, which is just worrying about the bottom part. And d of g would be where x can't be negative 7. So here's negative 7, empty spot. Everywhere else works. And then the third number line is where g can't be 0. And that's not about crashing. The third number line is about where this whole thing can't equal 0, which means the top can't equal 0, which means x cannot be 0. So here's a 0. Where is 0? Between 1 and 7. I got to be careful with that. 0's in there somewhere, empty spot. And now, I ask myself, where do all 3 lines overlap? And they only overlap from there over. All 3 lines have to overlap. Final answer is from 1 to infinity. Raise your hand if they had that one right. Awesome. Okay. Now you're good with what we did before, and that's the crucial thing, because if you get this, then this next step is easy. This next step is you're putting a function inside another function. So let's make one more set of f of x's. And this time, let's say f of x is going to be x minus 8. And then this one's going to be x squared. Sorry. Well, let's make this other one g. All right. Your first step is to learn how to do what's called a composition function. It's a function of a function, f of g of x. And what does that really mean? That means we're going to put the g function inside the other function. Well, this is the g function right here. I'm going to put it inside the other function. Where can it go? Inside the x. So what you do is you write out this one without the x. You go square root of empty spot where the x was minus 8. You remember doing that before? I kept saying put an empty spot where the x is. Now I drop in whatever was in this function. So that drops in here into the empty spot, and I have x squared. There it is. That's f of g of x. That again, those will be, if you get what you're doing here, those are really easy. And the harder part is remembering what number lines to overlap. Okay? And the 2 you have to do is, there's 2 number lines for this, not 3. You would think there'd be 3 like there was in the other one, but there's only 2. It's the inside one, so the domain of g, whatever's on the inside, and the domain of c. What is c? C is the composite. The combined one, yes. If you want to call it combined, that would work. But technically, that's a combined function. A composite function. All right, so one thing at a time. What's d of g? Well, with the g, that's easy. What's the domain of that x squared thing? Can that thing crash? No, so it's all real numbers, so that's easy. And the other one, domain of the composite, that's this new function. I haven't ever done a domain for it, so now I got to do a domain for this new function, as if it was a third function, like instead of f of x or g of x, it's like h of x or something. This new function, what would its domain be? Well, you'd say, I want x squared minus 8 to be greater than or equal to 0, and I'd solve that, right? So I'd want x squared to be greater than or equal to 8. And then how do I finish this? Square root, and you know how many people are going to do this? This will be the 15th time on a test where kids are going to go x greater than or equal to square root of 8. Why is that wrong? Absolute value. So don't just do plus minus. Do absolute value. And you're going to get eventually that the plus minus thing will screw you up. The plus minus will happen naturally from the absolute value. Now I got to split this up. And now think about this. Absolute value of x. No, it's not absolute value anymore. I'm taking the absolute values off. X is greater than or equal to square root of 8, exactly as you see it. And now this is important. X is, and it's going to be a negative 8, right? What happens when you change the sign? It flips. So this changes to less than or equal to negative square root of 8. So there's two answers. And it's crucial. And so many kids are going to forget that because they'll just forget this little thing about how when you have a square root of a variable, you need absolute values. And the absolute values force you to do two separate equations. And then a lot of people forget to switch the sign right there because they have the thing going from square root of 8 to negative square root of 8. The sign has to change. Okay, so where am I now? I'm at square root of 8 and negative square root of 8. I don't even know where they are, but it doesn't matter. As long as I have the positive one here and the negative one here. And now, can it be those spots? Yes, because it says or equal to. And then I should test. It's really not that hard to test. So I go back to my original function, which is right there. And I'm going to stick in a number like, what's bigger than the square root of 8? Like 10 or something. Okay? If I put in 10 squared is 100. 100 minus 8 is like 92. Is the square root of 92 crashing, or is that okay? It's okay, so it works. So it works in there. Another way to say that is it was supposed to be bigger than the square root of 8. See? And the other side, remember how it said less than? So I bet you anything, if I test over here, it's also going to work. So let me try something not quite as outrageous. I'll try negative 11. No, negative... Let's say square root of 8 to be like, let's make negative 4. We'll test negative 4 in here. Notice it's in parentheses because the x has a little parentheses. Square root of, or squaring that makes it negative times negative makes it positive 16 minus 8, which makes positive 8. Square root of positive 8 is okay. It didn't crash. It works. There we go. And if you tested anything in here, what's my favorite thing that's in there? 0. You'd find out it doesn't work. If I put a 0 in here, I end up with a square root of negative 8, and that's not allowed, so it doesn't work. Okay, so that's the hard part. Now, you know how to do the overlap thing. That's where they overlap. Negative infinity up into negative square root of 8. Bracket, union with square root of 8 to infinity. All right, I want to do one more example with you, and then we'll just do stuff off your homework. F of x is going to be 1 over x plus 3. And g of x is going to be square root of x minus 11. Okay, figure out what f of g of x is for me. That's the easy part. And then we'll do the domain in a second. I'll pause while you work on that. Okay, here's how you should have done that. The g goes into the f. This goes into that. I would write this as 1 over empty spot plus 3. I would drop in this into this. Square root of x minus 11. Can you get that square root out from underneath the square root? No. Well, you can, but it's really complicated, and we wouldn't expect you to do that. So this is good enough right here. You would not want to leave a fraction in a fraction, but there's no fractions here. It's just one big fraction. Okay? All right, now the overlap of the domains. Do you remember which two get overlapped? D of G and D of C. It's not always G, but it's always the one on the inside. This happens to be on the inside this time, so it's D of G. So see if you can do that. Well, one part's easier than the other part, that's for sure. What's the domain of G? Well, I go back up to this. And you've been doing domains for quite a while now. Hopefully you know x minus 11 greater than 0, equal to 0, sorry. X greater than or equal to 11. Okay, I can do that. Here's 11, greater than or equal to that. That was domain of G. You get that? Am I doing it right? Okay, I'm just making sure because I wasn't hearing much. All right, so now domain of C. That's this new function. This is the composite function. So I got to figure out its domain, and what domain is about is you should never let square roots be what? Negative. And you should never let the whole denominator be what? 0. So you have two things to solve. This would be a particularly tough one. This x minus 11 has to be greater than or equal to, you know what that's going to be? It's going to be the exact same thing. See what I mean? All right, so I can't, it's got the same exact restriction there. It's got to be 11's an important spot, but it seems like it works at 11. But here's the harder part, that the whole denominator would not be equal to 0. All right, tell me this, though. If you have the square root of x minus 11 cannot be negative 3, could you ever have a square root come out to negative 3? Can you ever have a square root come out to negative 3? No. So it will never be 0. That means that that would never cause this function to crash, and therefore that part is not going to cause any extra important point, because there is nothing that will make the denominator turn into 0. So all we got to do is use the same exact thing. So if it's these two that are exactly the same, then when they overlap, final answer is from 11 to infinity. Raise your hand if you knew that before I said it. All right. Now that was a tougher one because this denominator of the tough one was hard to do. So here's the main points. I'm not doing a third one, just generally speaking. If I ask you to do f plus g, what do I do with the two domains? Just overlap them. If I do f over g, how am I going to do the domain on that? How many number lines? 3 number lines. What's the third number line you got to add in? G cannot be 0. Good. And the last kind is if I do f of g of x, and the number lines there, how many number lines? 2, yes. And what are they? D of the inside, yep. And D of some composite. Good. All right, I think you got the main points. Now I'm going to do a couple of your homework problems with you. And I'll pause for a second while I hand those out.